Today's lesson is over section 3.7, where we will talk about the derivatives of logarithmic functions. Okay, so we have two new differentiations to talk about. So log of x with a base of a. So remember, a can be any value or any constant. And so I show the proof, and so in doing so, you're able to see that the derivative of log of x base a is 1 divided by x times ln of a. Okay. Now, we do the same thing with a natural log of x, and because that's the same thing as log of x base e, we can do the same thing, but what happens is ln of e actually cancel each other out because they're 1, and so 1 times x leaves you with x. So the derivative of ln of x is actually 1 over x, which is a very nice simplification. Okay. Now remember, you have Leibniz notation that you can use, and so I kind of reiterate that down there because there's some chain rule involved. Okay, so here I'm looking at some examples where I'm going to just find the derivative and simplify the following expressions using these new derivatives. So the log of x squared times e to the x base 4. So I take a chain rule, so 1 over x squared e to the x ln of 4, which is the value of a, and then I have to take the derivative of the inside, which is x squared times e to the x, which I need to use product rule there. Now here, there will be some times when you can simplify and things get canceled out. Like there, I was able to cancel out an x and e to the x, and gives me a simpler notation. Here, I have quotient rule for letter b, and so I got to take the derivative of the first, or the top, divide or times the bottom, and then subtract derivative of the bottom times the top. Then once I see that I have a negative 1 divided by x in common, I factor that out. And then there's a common ln of x in both of those, and there's 1 plus 1. That gets me 2, so I can multiply that to that fraction. Gets me negative 2 divided by x. Then I choose to multiply by the reciprocal, and then that gets me my final answer there, which is a very simple answer too. Okay, letter C. Now here there's an ln in front. And so it's easier to deal with this by separating it using your quotient property for ln. And so I set them equal. So remember, that means division means subtraction between the top and the bottom. And so then I can use the power rule for those, or power property, to move the 4 and the 3 down. So I don't have to do power rule with this. And so then I could take the derivative of 4 times the ln, which is just 1 over 4x minus 1. Now 4x minus 1 and 2x plus 6 have a derivative on the inside, so I have to take the derivative of those using chain rule. But then it's pretty easy to simplify from there. And there's a 2 in common with that last fraction, so I'm able to get 2 fractions. Now you can make common denominators and put them together, but that's up to you. Okay, so one of the tactics, kind of like that one, is to be able to use some log rules to help us make finding the derivatives a little easier. So what we're going to do is we're going to take the natural log of both sides first, and then use some log laws to help us simplify, and then we'll take the derivative, and then we'll solve the resulting equation for dy over dx. So the first one I have y equals x to the 1 divided by x power. So here I take the ln of both sides. That allows me to move the 1 divided by x out front. I'm going to change that to x to the negative first, and which makes it product rule, but it's really simple to take the product rule there. So derivative of the first times ln of x, and then derivative of the second, which is 1 over x times x to the negative first. And then I'm going to simplify. Notice I have dx on the right for both of those, and then it's 1 over y on the left because it's ln of y. And so here I'm going to simplify a little bit. I'm also able to factor out a 1 divided by x squared for both of those terms. Now here, you're usually going to get the same kind of setup with these, because y will be by itself on the left, but we do have to take the derivative because we add in an ln. And so then to get dy over dx, I have to divide by dx, but then I have to multiply by y, and it will be multiplying by y each time. Now I don't want my derivative to have y in there, and so I go back to my original equation, and I know what y is. It's x to the 1 divided by x power, so I'm going to insert that in, and then I get my final answer for dy over dx. Okay, now here for this one, I'm going to do the same thing, take ln of both sides. Now here, because you have multiple things multiplied to each other, then you can use the product property and separate them all with addition. And then we can use the power property for all three of those because they all have exponents, so I move them all down in front. And then from here, I want to take the derivative of each of these. Now, because most of them are multiplied by a constant, I don't have to do any product rule. Now the middle one, ln of e, is actually 1, so I can ignore the ln and just take it the derivative of x squared, which is 2x, which is very nice. The second or the last one has a derivative on the inside, so I have to use chain rule there. And then I'm going to simplify inside the parentheses or the brackets, so I get something a little nicer, but then I'm going to do the same in the process. So divide by both sides by dx, multiply by y. Now if you notice in that step before, I didn't write dx for each and every one of them. I wrote it as a whole because they're all dx, so that's one little trick to save you a little bit of time. You can kind of write it as a factor term there. But then once I do that, I need to insert in what y is, and then I get my final answer. Okay? Have fun.